In this video, we are going to see how to draw the first angle projection of an isometric view. Now, let us consider an isometric drawing, something like this, with all the dimensions given. We are going to draw the first angle projection of this drawing, which means we are going to draw the top view, front view, and side view. As it is a first angle projection, this is the location where I'll be drawing the front view, and here I'll be drawing the top view, and here I'll be drawing the side view. And care should be taken that between each view there should be a gap of 20 millimeters maintained. Now, in the beginning, I'll split the whole paper roughly into quarters like this, and something like this. This need not be exact. This is just a way where, just a place where you will begin your drawing with. Right now, this is where the front view has to be drawn. So I'll have the drawing somewhere here for your reference, and then let us begin drawing. Now look at the dimensions which are given on the drawing. So the base, I'm going to draw the front view here. So the base, it is almost 120 millimeters. So let me draw from here, 120 millimeters. Okay, this is the line. Then we have to draw a line parallel to this line, which is going to be 10 millimeters apart. So 10 millimeters apart, I'll draw another line which is also 120 millimeters in length. Now, we'll be using the set square to draw all the perpendicular lines. As I have mentioned, place the set square's edge very close to the t square, so that you make sure that the set square is placed vertical. Okay, next. So this is 120. So the midpoint of 120 is 6, which is somewhere here. That's going to be the middle of the drawing. And then we have a rectangular structure which is placed perpendicular, which in the picture is a cylinder. In isometric view, it is a cylinder, and they say the diameter of the cylinder is 6. So which means in our case it is going to look like a vertical rectangle, which will be 3 millimeters on that side of the center, 30 millimeters on that side of the center, and 30 millimeters this side of the center. So just to say which is the 3 millimeter mark, this the 3 millimeter where I'm keeping. So I'll have to draw a line here and draw a line here. I marked it. So now I can place my t square in proper position, and then I'm going to lock it so that it is not going to move. The height of the rectangle is given as 40. So I am starting from here using the set square. That's 40. So let me draw a straight line. Similarly here. That's it. So this is going to be the cylinder that appears rectangular in the front view. Completed. The structure is complete now, right? What next? The next thing is there are inclined lines which have to be drawn on either sides of the, which is something going to be like this. So I'll always make use of the t square when I'll try. Okay, so what I'm going to do is I'm going to make use of the set square, and I'm going to join these dots. Similarly on this side, from here to here, like this. So this is how the front view is going to look like. We have missed only the circle here. We'll draw the circle now. To draw the circle again, I'm going to find out the midpoint, or in the drawing if you find, they say that from the top it is 10 millimeters below. So it is 10 millimeters below is a point here. So the center of the circle should be somewhere here. The diameter of the outer circle is given as 20 millimeters, which means it has a radius of 10 millimeters. So I'm measuring a radius of 10 millimeters. I'm going to start from here, 10 millimeters below, and then firmly hold your compass and then draw the circle. It is done. Now this is the outer circle. The inner circle, we found the center of the circle, so it is easy to draw this inner circle. The inner circle is having a diameter of 10 millimeters, which means the radius has to be 5. I measured the radius as 5. I'm placing the circle, I'm placing the compass in the center, and then I'm going to draw a line. Now as the circles get smaller, it is difficult to draw with compass. So in this place, if you have a circle template, you can always use a circle template and draw the circles. Now that's how it looks like. Now this completes the front view. Now as a thumb rule, when we draw the top view here, the distance between the front view and top view should be 20 millimeters. So this is 20 millimeters somewhere here. I'm measuring 20 millimeters, and I'm just going to mark a reference line like this, just to indicate where the top view has to start. And the other thing that I would always do is the edges of the top view and the edges of the front view should coincide one another. So what I'm doing is I'm holding the set square perpendicular, and I am trying to project all the perpendicular lines. Now these are the perpendiculars. So let me project the center also. It is always helpful when I start constructing. Okay, these are the lines that I have drawn. Right, so let us draw the top view now. Again, so you can see that I have projected this edge and I have projected this edge. So the top view should be somewhere between this and this, isn't it? So now I don't have to measure. The only thing here I'm measuring is the 20 millimeters gap between the top view and the front view, which I already did. And now just join the lines like this. And then the height of this rectangle should be 70. So I'm placing it like this, and then I'm making 70. So I've got the height, bring it down, close the drawing, and then let us complete the drawing likewise. So that's how the top view will look like. Now the whole rectangle here is 70 millimeters, so which means the midpoint is 35 millimeters. So I made a dot at 35 millimeters because here I'm going to make a circle. Now what should be this radius of the circle? It should be, the radius should be from here till this line. No, I don't have to measure, although the dimension is given on the drawing. It is given as 60 millimeters, which is 60 millimeters is the diameter. So this should be 3 millimeters. So just to measure it, you can see that it's exactly 3 millimeters, and I took the distance from here to here as 3 millimeters anyways. The center is marked. Place the circle, place the compass firmly, and make a circle like this. Okay. The diameter of the inner circle is given as 40 millimeters. So in our case, the radius is 20 millimeters. So place the compass exactly on the same position from where you drew the outer circle, and now make a circle like this. We are done. Similarly, this is the midpoint that we have marked before. So from the midpoint, I'm just drawing the midpoints here, so that will be easy for me to construct a 10 millimeter line. So when I'm doing a 10 millimeter line, 5 millimeters on top and 5 millimeters on bottom of this particular mark. So I'm using the set square to mark it. So from here to here, that's how it has to be. Once the marking is done, I'm going to take my T-square and then draw the lines. Now what I am drawing is the top view of this inclination. So this is done. Now the one thing that we missed is these circles will appear somewhere here, and in our drawing, in the dimension, it is given as the thickness has to be 3 millimeters. So from here, from this edge, I'll be drawing 3 millimeters. 1, 2 and 3 millimeters go somewhere here. So I'm drawing a simple construction line like this. Now what I would do is, I can either turn this around and then I can project it like so from this outer diameter. Done. Or the other way of doing it is, you don't have to turn your T-square, but you can use your set square, and then you see that's the reference, and from here I can draw a vertical line like this. After drawing the line, join these two points. This completes our top view. So what we have now is the front view and the top view. The next thing that we have to do is the right side view. So again, when you want to draw the right side view, the distance between the front view and right side view should be 20 millimeters. So we'll do the same thing as I marked here. 20 millimeters is somewhere here. This is the 20 millimeter mark, right? From this, I'll be drawing. From the side view, it is going to be 70, isn't it? So to make my measurements easier, what I'll do is, I'll try to project all these horizontals. I'm projecting the horizontal lines like so. There you go. Now let us continue the side view. The height of the side view is going to be exactly of the same height of the front view, and the width of the side view will be exactly the width of the top view. So top view is 70, so the width has to be 70. So 70 means from here I'm measuring 70 now, from this point, which is 20 millimeters away from the front view, and that's going to be the line where I will be drawing the top view. So let me hold it like this, draw the line for the top view, just to reduce my. So what I'll do is, I'll make a 10 millimeter line, because on the side view this will appear on the side view, isn't it? And the height of this is 10 millimeters. So again, I don't have to measure. All I can do is, I can keep the T-square along this edge and then draw it like this. So this completes the width of the side view. Similarly, let me draw this, and I'll draw this line. So as the width is 70 millimeters, the midpoint is 35. So I'm just drawing it like this. And again, the diameter here, or the diameter of this circle, was 60. So then I'll be drawing 30 millimeters this side from the center and 30 millimeters from this side of the center. I'm going to mark lines so that I'll be completing the rectangles like this. that's the side view. Similarly, I'll be drawing a 1 millimeter mark from the middle, which is 5 millimeters this side and 5 millimeters this side, so it becomes, this is the side view of the inclination that you find here. Right, so now this circle which is projected here will appear here somewhere, and so what I'm doing is I'm going to keep it from this edge. I'll roughly mark where it comes, and again here I'm just marking its location like this. After doing that, the thickness of the projection here is 3 millimeters, so 3 millimeters away, which is 1, 2 and 3 millimeters, is somewhere here. I'm going to draw a vertical line, and then I'll complete this structure like so. So what we have done till now is we have drawn the side view as well. Now again I am trying to remove all the construction lines like so. Okay, you can have the construction lines if you want to, because when we try to complete this drawing, you will have to draw the dimensions, so in that way it would be helpful. Now just for the teaching purposes, I have removed the construction lines. Now what you have here is the front view, top view, and you have the side view. Now the most important thing in the drawing is the hidden lines. So in this angle, which is in the front view, there is hidden lines, which is, let me lock this so that it doesn't move. The inner circle will not be seen here, so that should be the hidden line. So mark the hidden lines with dotted lines. Similarly, the next hidden line comes here. See, what I'm doing is I'm not measuring anything. I'm trying to project the inner circle from here to here. So this is the reference of the inner circle, and I'm projecting it like this. I'm using the t-square to do that, and if you see here, now this is the inner circle. I'm keeping it straight, I'm doing it. Similarly, here you have the inner circle, isn't it? That is not seen from the top view. So what I do, I'll do the same thing again. I'm placing the t-square. I'm placing the t-square in a position and locking it. Then with the set square, I'm moving it till the edge. Look at this, and I'm holding it firm. Then draw the hidden lines. Same thing here. Okay, the hidden lines are also drawn. Now what is the next thing? There are also hidden lines that you can find on the side view. So which is in the right side view, the inner circles are not visible. So I'll do the same thing here. Unlock it, bring it down. I'm now referring to the inner circle here, so this should be the hidden line. Same thing, unlock, bring it down, draw the hidden line. Done. Now the only hidden lines which are missing is these inner hidden lines, which will be here. So in this case, again, the distance is 1 millimeter. I can either measure it 1 millimeter, or I can project these lines from here, make it 45 degree and bring it up. Just to keep it simple, what I'm doing is I'm measuring it and then I'm marking it. So I mark the inner diameter, and then I'm marking the hidden lines. So this completes the drawing. Now after completing the drawing, you'll have to mark the dimensions. So to make the dimensions, let us have all the I'm not going to mark all the dimensions. I'm going to mark a few dimensions from which the drawing can be drawn. We can finish the drawing by completing all the center lines. The center lines are usually the chain lines, so which is drawn in the center of every circle. Now you can find there is a circle here, so let us draw the center line. Similarly, there is a center line which comes here, like so, and then the center of this cylinder is also drawn like so. And then we have one cylinder here and there is a circle here, so let us draw the center line again. Keep it in the center of the circle. Draw chain lines. Similarly for the circle here. Last, the horizontal center line for this one. That's it. This completes the first angle projection of the given isometric view. In the next exercise, we'll consider the same isometric drawing and draw the third angle projection. In the third angle projection, the procedure is going to be the same. The only difference is the location of the front view, top view and side view will be different. So what happens is, the front view will be drawn here, top view will be drawn here, and the side view will be drawn here. So it is just, you will be switching the position of the three views. So this is the location where you will draw the top view, this is the location where you will draw the front view, and this will be the location where you will draw the side view. For the same isometric view, you will repeat the drawing and then you will draw the orthogonal views, but this time you will be following the third angle projection.